There are a lot of ways to make cloud shapes within Vue, and really depending on whether or not you want to use default detail settings or design them within the function. In order to get a lot of specific cloud types, you really need to define your own density. So I'm going to show you how you can create Wispy type turbulent clouds, really relying more on that density function. So starting with the scene, start scene 1. I'm going to open up the atmosphere editor, and we'll start with adding in from the Spectral 2 directory a cloud layer of Wispy Stratus, which we will be modifying and customizing. I'm going to turn down the detail amount. We can also reduce the height. And then we're going to edit the material. Turn off the custom cloud layer profile, and then edit the function. Now the gradient amplitude noise node has already been added in and is used to control this. It has a frequency option, which is different from just the gradient, and it'll allow you to increase the frequency of the amount of noise in a certain axis. So if we increase 3 on the Y, we're going to get a lot more information being passed through the Y. I'm going to set this to 1 for now. But instead of using a standard turbulence node, which may not match what we currently have, and what I want to do is use a noise node in order to act as a turbulence. Well, for this we need to design kind of a custom node and really break down the vector to be controlled by a number. So we're going to need a math node. I'm going to right click, add a math node, vector operation, and use the composer 3, which is going to take an XYZ number and output it as a vector. So that way we can tie this to the origin of the noise node and control any origin with a noise node. Want to have some additional options for this. Basically having a multiply per axis. So I'm also going to add in a filter, set it to multiply, and then we can add in 2 more. So we're going to have 1 for the X, 1 for the Y, and 1 for the Z. I also like to have the option of not using the noise or the tied-in multipliers. So what we can do is turn off individual axes. And this can be done by creating kind of an on-off switch, which is a pretty simple setup. We can add in a blender, clip ratio 0 to 1, and we're going to need 3 of these. But first what I want to do is right-click, add in a constant node, Boolean number. This will output a value of -1 or 1. So if checked, it should be an output of 1. And then since we're being clipped, it won't go below 0. And that way we control between 0 and 1, which is going to be the 2 inputs on top. So we're going to control the ratio with a Boolean number. And then we'll be connecting to a constant number of 0. So we're going to add in a constant number 0, and that is going to be, let's go ahead and do input 0. So that if it's checked on, it will go to 1, which will be our multiply. So this is a very simple on-off switch. If you're using Vue 7, what you can do is just use the slider for the blender and output that in your meta node, because we're just going to be making a meta node out of this. So instead of having a checkbox, you'll just have a slider going between 0 and 1 to turn it on and off. And I just want to have one of these for each of the axes. So what you can do is copy all 3 of these, or select all 3, Control-C to copy, click and paste, and then paste again. And you just need to replace those multiplies, or where the links are being connected to. So it's a pretty straightforward setup. and then the multiply overall is going to be connected to the main number input. So let's go ahead and make the meta node. We're going to select all of these nodes, go up to the top, make meta node, double click to open it, and our output is going to be a vector. So we're going to right click, add output vector 3, delete that double output, which would be a number output, and we need to add in an input, double input, and we can connect all the multiply. And it looks like it's not really allowing me to connect it. Go ahead and try again. Looks like a little bit of a bug. So I'm just going to close this out, ungroup the node, and first connect all the multiplies to this noise node. Reselect all of those, and we can make a new meta node, which is going to automatically add in that double input. So we can just call that number, rename it, and then once again add the vector 3 output. So now we want to make these options available, and basically what we can do is select the Boolean numbers and publish them. And I'm going to give this a group name, use axis, and then x, and then we can publish the next as y, and the last one as z, and then we want to publish the multiplies as well. And then we can also give these specific names, so multiply the x, multiply the y input, and multiply the z input. Click OK. And now we have basically a turbulence setup. I want to go ahead and save the meta node. And I've already created this. It's just called number to vector with multiply. I'll just give it a 3 on the end because this is my third version of it. My personal version is basically the same thing. So the naming is a little different. To affect the vector, I have it set up x, y, or z, and then the multiply vector x, y, z. It's a pretty handy little node, and this way we can use any noise as a turbulence. In that way we have the exact same values set up. It looks like there might be a little problem displaying the gradient amplitude. So go ahead and reset that just by changing the type. What I want to do is select the noise node, add in another noise node, which is going to become our primary noise. Connect that to our main output, and then we're going to connect the meta node to the gradient amplitude and our origin to that meta node. We can then multiply the individual axes depending on the direction, which way we want to have the turbulence, and also depending on which axis we want to affect. So this way we've created our own custom turbulence, and it can end up being a lot more powerful than some of the other nodes. Using the just standard turbulence nodes, you'd have to match up all the different values, and it may not return the same output. So now we're basically stretching this noise around, really more intensifying the current setup. But what I want to do is take the frequency amount and increase it for the turbulence. And let's go ahead and do that on the y. I'm going to type in a value of 12. So on the y, we're going to have a lot more kind of curling. And let's go ahead and take a look and see how this is going to render. We might need to make a few adjustments to the cover and some other settings to see it entirely, because right now it's not really showing up. So we'll increase the cover amount and just see if we can get it to start showing up. Might need to adjust that scale because it is rather large. So we'll go ahead and bring it down to 0.2. And it looks like we also need to change the overall scale. So if we go back into the material, there is a function scale change. So I do want to set that to 1 all the way across. And we're going to define an increased scale on one of the other axes. And it did look like one of the main problems here, I did connect the wavelength rather than the origin. That's not really going to work out too well for this effect. So I do need to make sure that I'm grabbing the origin, and that'll look a lot better. I'm going to decrease the amount. You could also reverse it too. If you wanted to have this lower node have the increased frequency, and go back to the noise and set that to 1, that could sometimes work a little better. I'm going to go ahead and change the Y to 2 on both. And let's take a look at how this cloud layer looks. And so you can start to see the stretching and the turbulence around the initial node. And what we really need to do is kind of break off specific areas of the node, mix it in a little bit more so that it's not this constant amount of cloud, and we can get something a little wispier. It also might be a little too large at this point. But you can start to get an idea overall of how this is affecting it. So we're going to go back, edit the material, go back into the function. In the meta node, I want to make sure that the multiply is set to 10 for all of them. We can also adjust the individual axes, how much to multiply, or even type in a value higher than 10. You can reverse it to divide. So there's a couple of different ways you can modify that. I am going to increase the X frequency slightly to about 3, and then add in a blender node underneath the gradient amplitude that's being distorted, and now connect it up to what we're using for the distortion. And now what we can do is use a blend of min or max, and start to kind of cut out areas and really just pull out what it is that we want, and intensify it a little more. There's a lot of different ways we could set this up. Let's start with a min amount. I'm also going to go in here and adjust the scales for both to bring them down to about 4, because it's still a rather large cloud layer. And it's starting to get a little more interesting. It does look like maybe the detail amount's a little too high. I'm going to turn down the feathers, sharpness, and then go back into the material and decrease the roughness of the cloud layer detail. And we can adjust the minimum value. Another thing you can do, which is pretty neat to help cut this away, provide a little better of a mix in turbulence, is to use the rotation and twist math node. So I'm going to add in math node vector operation rotation and twist. And with that selected, I can select the link between position and the gradient amplitude, and then add in a math node to add that as part of the link. We can delete the placeholder, and then we can apply a little bit of a twist on one of the axes. Using twist instead of rotation, because then we can still have basically the same position for the distortion. Close that, click OK, close them all out, and we'll start to see a little bit of a wispier cloud showing. Really depending on what part we need to cut out further, we might need to twist in another direction or modify the blender. In this case, I think I want to reverse the connection to the blender on the bottom, add in a filter node, set it to opposite, and that way we're going to have reversed output. It should look a little bit better. And I'm going to go ahead and increase the height of the layer, so we can see more of that cloud layer showing up, a little more of the distortion. But you can start to see the partial blend, where it's a little bit denser and then starts to kind of fan out into the thinner zones. It's really a matter of just kind of adjusting that minimum amount or the input. If we go back to the material, setting some of these other values and changing them as well can also help. We could also switch that over to the max amount. Just kind of bring that in. So now if we take this and start to mix it in with detail, increasing the detail amount, we'll be able to break apart the cloud shape a little more and make it look more realistic. But this way we can kind of control those initial shapes and patterns, really just with the density, and then bringing in the detail later. Another setup that works quite well for this is if we switch around the blending method. What I'm going to do this time is go back into the node and delete that opposite, delete the blend, and connect each of these two values, where I'm going to use one separately and then one that is distorted. So we'll just connect the blender to the gradient amplitude, and then we could also take the ratio and connect to either one of these. And that'll mix it up a little bit more. Or take the ratio and connect it to the distorted one. And it can create a very interesting looking cloud layer. Sometimes with something a little bit of a better blend. I've also included several setups using this main setup I just showed you on that meta node, with a lot of different cloud turbulence that you can kind of reverse engineer. If you take a look at Wisp number 2, take a look at the setup. It is set up basically the same way, where we have the gradient amplitude being blend with the add mode, and then a rotation and twist setup, and then using the amplitude with that number to vector meta node we created, a couple of different values, higher of a multiply on the Z to stretch it up more to curve around the main shape. And then there's some additional values set on the frequency for the gradient amplitude that make it just a little bit different. If we take a look at the way this looks, so we have a pretty interesting variation, but based on the same setup. And if we wanted to make this more of a higher altitude cloud and maybe reduce the overall lightness of it, if you wanted to have it very high altitude cloud, one easy thing we could do is just take the density and really turn it down. That's going to really just kind of fade it out and lighten it. It'd make for a really good distant layer. And this is still rendering out, so it's a little pixelated. But it gives you a good idea of what it's going to look like. Now I am using noise nodes just to cut down on rendering time. If you want to have something broken up a little bit more and the detail settings aren't really giving you what you want or the look that you want, you can change the noises over to fractal. And if we go into the material for this, what you can do is select the noise and just click on fractal. So it's going to replace it with a fractal and basically apply all of the settings to the way they were before. The gradient amplitude will also be set up if you go to Edit, and we can see the exact same values as before. So this way we can now adjust a roughness, and with zero roughness it's basically a noise. As we increase the roughness, the fractal elements start to show up a lot more, and we'll be able to really break up the cloud layer. It will take a little bit longer to render, but it will produce a better looking layer. Depending on the scale of the function, the fractal, you would want to avoid any roughness settings larger than 0.5, because it's going to cause a lot of grain and a lot of little in-between values, and that could cause grain within the lighting and the anti-aliasing. So you can take a look at a lot of these included wispy type clouds and get a good idea of how you can create a turbulence. And using those larger shapes in order to produce a turbulence for basically a duplicate, you can get some very nice looking cloud layers. So feel free to play around with those settings, even adjusting just the frequency, some of the different scales. You can create really nice looking clouds. If you're finding that they're just too squished, and you really want something to climb a little bit higher, but not with all the fine little details, one thing you can do is go into the material and just take the overall function scale and increase the Z scale, which will stretch it all out so that if you're using a more limited layer, let's go ahead and increase this to 6, we can show a smaller portion of the function and really see a bit more of the turbulence kind of curving around those larger shapes. Now this one might have been stretched out a little bit too far, so you might want to reduce that scale of the Z, because a lot of the details are being cut out because the height isn't high enough. Also, because of all those in-between values being stretched, there is a bit of grain. So that might be one thing to pay attention to. So this is basically the kind of turbulence you would use for the density layer. There is another type of turbulence available which will affect basically everything, the cloud layer detail and the density, which is using the global transformations. You can set up a cycling for looping and rotation, also the twist option, and then a turbulence. So that's also going to affect the detail layer. In version 8, the mapping has changed a little, so these turbulence settings might need to be a little different than they would be in version 7.